Today we are going to talk about coordinate trigonometry. With coordinate trigonometry, we're going to look at sine, cosine, tangent, and their reciprocals on the coordinate plane. So the way this works is if we have a coordinate point on the system in terms of x comma y, then if you draw a line straight down to the closest x-axis, that would create a right triangle. And so that means the distance, the horizontal distance is your x, and the vertical distance is your y. And then your theta is always in standard position, so that means it goes around till it gets to that terminal side. So therefore, this would be your theta. And then your hypotenuse is your r, which stands for your radius, okay? So when we're doing this, that means that sine is your opposite over hypotenuse, so it's y over r. Cosine is x over r. Tangent is y over x, because opposite over adjacent, and then the reciprocals. When we're trying to find a missing side, like the radius or the x or the y, you use the Pythagorean theorem. So if we're using a squared plus b squared equals c squared, in this case, that would mean it's x squared plus y squared equals r squared. So that means that to get r by itself, we could square root both sides of the equation. And so that means your r value, your radius, can be found by taking the square root of x squared plus y squared. So then let's look at our first example. Problem 1 says, let angle theta be any angle in standard position whose terminal side contains 0.5 comma -8 and find the 6 trigonometric ratios. And then we're going to find the angle of rotation. So if we first plot this point, a positive comma a negative should end up in the fourth quadrant. So that means we go to the right 5 units and down 8 units. And we plot that coordinate point. And then you'll connect it to the origin. So then we can create our right triangle. The horizontal and the vertical side make a right angle. And so then that means it went to the right 5 units and down 8 units. So that's -8. So we can use Pythagorean theorem to find what the radius is. So that means your r equals the square root of 25 plus 64, since 5 squared is 25 and 8 squared is 64. So if we add 25 and 64, you should get square root of 89, which does not reduce, so we'll just write square root of 89 there. And now you can find your 6 trigonometric ratios. So if we find our 6 trigonometric ratios, first of all, sine is opposite over hypotenuse. Your theta is always between the terminal side and the origin. So that means theta opposite would be -8 divided by the hypotenuse, which is square root of 89. We need to rationalize that. So that means we want to multiply it by square root of 89 to rationalize the radical, which means that sine is equal to -8 square root of 89 divided by 9. Then we basically do the same thing for cosine, but remember cosine is adjacent over hypotenuse. So adjacent would be 5 divided by square root of 89. And so then if we rationalize that using the same process, you should get 5 square root of 89 divided by 89. So then finally, if we do tangent, tangent is opposite over adjacent, so that would be -8 over 5. So now we can find the reciprocals. If we find the reciprocals, the reciprocal of sine is cosecant. So that would be negative square root of 89 divided by 5. And then secant is the reciprocal of cosine. So the reciprocal of that should be square root of 89 divided by 5. Wait. Eight. Cosecant should be -89 divided by 8. And then cotangent, the reciprocal of cotangent, would be -5 over 8. So now we have all 6 trigonometric ratios, but that's not all we're supposed to do. We're supposed to also find the angle of rotation. So I could find the angle of rotation by saying tangent theta equals -8 divided by 5. So then, remember when you want to solve for an angle, you take the inverse of it. So I could say tangent inverse of -8 divided by 5. If I put that into my calculator, I get about 58 degrees. But that's not the angle I'm trying to find. It says angle theta is in standard position. Standard position means that it's going to go in the clockwise position. So that means your theta is actually in counterclockwise position all the way to here. Because we just found that that angle inside the triangle is 58 degrees, you know an entire circle equals 360 degrees. So that means your angle of rotation is simply just 360 minus that 58 degrees. And so that means the angle of rotation is 302 degrees. So then the second type of problem we did was where we're given a certain piece of information and we want to figure out which quadrant is it in so that we can then find the remaining 5 trigonometric ratios. So here we have cosine is -3 divided by 7. So if cosine is -3 divided by 7, then we automatically know that its reciprocal, which is secant, would be -7 divided by 3, since it's just the reciprocal. But now we need to figure out the other pieces of information. So cosine here is -3 over 7. Well, cosine theta is x over r. Your radius is always a length, so your radius is always positive, which means we need to figure out what quadrant is this in, given the information that we have an x value is negative. So if we look at this, you know, in the first quadrant, it's positive, comma, positive. The second quadrant is negative, comma, positive. The third quadrant is negative, negative. And then the fourth quadrant is positive, negative. So because cosine is negative, that means that it has to either be in the second quadrant or the third quadrant, since that's where cosine is negative, since cosine is the x value. So then we have to look at our other piece of information. Our other piece of information says that tangent is greater than 0. Well, tangent is y divided by x. So y divided by x means that we need to divide these two. If I divide a positive divided by a negative for quadrant 2, I get a negative. If I divide a negative divided by a negative, I get a positive. We want tangent to be positive since it says it's greater than 0, which means of these two quadrants, we're going to put the information in quadrant 3. Okay, so that's how you determine what quadrant it's in. So now let's do that. So if we put it in quadrant 3, let's draw our right triangle. Put in theta. It says cosine is -3 divided by 7. So adjacent would be -3. Your hypotenuse is 7. So that means we need to use Pythagorean theorem to find out what is the missing side. So we have y squared plus -3 squared equals r squared. So that means y squared is 49 minus 9, since -3 squared is 9. And so then that means y squared is 40. So to get y, we square root both sides. So right now, y is the square root of 40. However, we need to reduce that. That breaks into square root of 4 and square root of 10 in terms of finding a perfect square. So that means that this side should be 2 square root of 10. Okay, so now we have all the information we need. So now we can actually find our 6 trigonometric functions. Okay, so if we find the remaining 4 trigonometric functions, sine theta is opposite over hypotenuse, so that would be 2 square root of 10 divided by 7. And then its reciprocal is cosecant. So that would mean it's 7. Oh, wait, this should be negative 2 square root of 10 because of the fact that it's in the third quadrant, negative, negative. So that means that sign should actually negative 2 square root of 10 divided by 7. So then we have cosecant is 7 divided by negative 2 square root of 10. So then if we rationalize that, that would be multiplying the numerator and denominator by square root of 10. So that means that cosecant is negative 7 square root of 10 divided by 20. Since square root of 10 times square root of 10 is 10, and 10 times 2 is 20. So then finally we just have tangent. Tangent is opposite over adjacent. So opposite would be negative 2 square root of 10 divided by adjacent is negative 3. Well, you know, a negative divided by a negative is positive, so that means that tangent is actually positive 2 square root of 10 divided by positive 3. So then finally, we just need to find cotangent. Cotangent is the reciprocal of tangent, so that means that we'd have 3 divided by 2 square root of 10, which means we need to rationalize it by multiplying the numerator and denominator by square root of 10. So then that means we have 3 square root of 10 divided by 20. So your 6 trigonometric functions are negative 3 over 7, negative 7 over 3, negative 2 square root of 10 over 7, negative 7 square root of 10 over 20, 2 square root of 10 over 3, and 3 square root of 10 divided by 20.